Okay, so in this video, I'm going to use the 9.5 task from the book to teach you guys how to find the correlation coefficient using Desmos. Okay, so before we get started, the correlation coefficient, to give you a definition, is the measure of the relationship between two variables. Okay, so two variables we're usually talking about are x and y. So in this case, we're going to start with this table F here. Okay, we're going to use this table. Remember, the top ones are the x's, bottom ones are the y's. And so I'm going to show you how to input this table into Desmos. Okay, so when you get to Desmos, first thing you're going to do, click on a new space, hit the plus sign, then go to table. Okay, what that's going to do is it's going to give you a two-column table with x's and y's. And what I'm going to do real quick is just go through and put all of these x's and y's again from that same table into Desmos. Okay, so fast forwarding, as you can see here, I put all of the x's into this column, and then I put all of the y's into that column. You just type them in, and then what that's going to do is it's going to spit out all of those points on your graph. Okay, not going to connect them, just going to make points. So what we're trying to figure out, the correlation coefficient, is how are these points related? In other words, how sure are we that we would know where to put the next point in the pattern? Okay, so to figure that out, we're going to go down, make a new space in Desmos, and we're going to type in y1 and then the tilde sign. So the tilde, you have to hit shift, and then it's the button right under the escape key. Should look like that. So y1 tilde, and then it's m x1 plus b. Okay, so basically y equals mx plus b, but instead of equals, it's a tilde, and then there's a 1 with a y and the x. Okay, so what that does is that's gonna print out the line that would best relate all of those points, like, most closely related, making a line through all of them. Okay, so as you can see in this one, all of those points are in a perfectly straight line. So when that happens, we're going to say that the correlation coefficient is 1. Okay, so remember, if all of these points line up in a straight line, a positive straight line, remember this is going up, we're saying that the correlation coefficient is 1. Okay, and so you can find that. It actually tells, I told you I was going to have you find it on Desmos. It tells it for you right there. It tells it to you right there. Okay, we are doing the statistics module right now. And so you can see it's under the statistics thing. Oops. Okay, so whatever the R is, that's your correlation coefficient. Okay, so again, when it's in a perfectly straight line, our correlation coefficient is going to be 1. Okay. It also tells you like the y-intercept is here. Anyways, okay, now we're going to do another one with a different correlation coefficient. So I'm going to pause it and clear all this, and then start a new table. Okay, so fast forwarding now. If you look on the left, I put there's a new table in. So now what I'm doing is I'm using table E. Okay, so you can see I'm using this one here. So the 2, 2.3, 3.3, and then 4.74, 4.2. So that's what I'm using here. Okay, so as you can see now, these dots are not so closely related. Okay, they're kind of scattered, kind of random. So we're expecting it shouldn't be close to 1. Because these dots don't make a straight line the way the other ones do, so it should be pretty far away from 1. Okay, so to figure out what the correlation coefficient is, we just, again, y1 tilde m x1 plus b. And then again, we go down trying to locate the correlation coefficient is r. So if you look down here now, if we round this, that's about 0.07. So the correlation coefficient for these x's and y's is 0.07. That's almost 0. So as you can see, the closer we get to 0, the more spread out the dots are going to be. Remember, we have 0.07 here, and look at all of these dots. They're almost, it looks like a scatter plot, kind of. They're scattered around. There's not really a strong relationship. So there's not really a strong correlation coefficient here. Okay, so again, fast forward, put in a new group of points over here on the left, and this is coming from A on the task. Alright, but again, whatever table you're given, whatever your x's and y's are, you just input them like this. Okay, so now if you look at this group here, they're a little bit closer together, not so far spread out. Okay, so let's see what the correlation coefficient is here. So here, again, if we do y1 tilde m x1, and to get the ones, you just hit 1, y and then 1 after, plus b. Okay, so there's our line that kind of goes through, it's the line of best fit, kind of goes through the points. And if we look at this correlation coefficient, it's a little bit higher, about 0.5. Okay, so 0.5 is kind of like right in the middle, which is kind of like what we were saying. This one, points are closer together, but still we're not, completely sure. They don't completely form a straight line. Okay, but they are closer together. So somewhere in the middle, expect something in the middle of 0 and 1, about 0.5. Okay, something very, very linear is going to be 1. Dots that form a straight line, it's going to be 1. Okay, dots that are completely random, closer to 0, like we got the 0.07. Okay, we're going to do one last one now. What happens if it's negative? Alright, so fast forward again, last time. So now I'm doing C from the task. Okay, it doesn't, whatever your table is, again, you just put it in the same way I did mine. Numbers could be whatever. So now when you look at this one now, these are pretty close to a straight line, so we should be thinking it's close to 1. But this line here, we're going to see what happens when we make the line of best fit. So if we type in y1 tilde m x1 plus b, now they're pretty close to the straight line. So if we look at our correlation coefficient, it should be close to 1, and it is. It's like 0.94, but there's a negative in front of it. And if you think about that, if you look at this line, would this line have a positive or a negative slope? Line's going down, so it would be negative. So again, close to a line, it's going to be close to 1, the closer it is to a line. But if it's a negative line, if it's going down, it's going to be close to -1. Positive line is going to be close to +1. Completely random, it's close to 0. Somewhere in the middle, about 0.5, somewhere right in the middle.